Hello everybody, and welcome back to our discussion of selections, joins, and relates. We've talked about selections so far, about why you would want to do it, several ways that you would do it in general. You could do it by selecting, just clicking on the screen. You could use the Select by Attributes tool or the Select by Location tool. Well, now we're going to cover a topic called selection types, and these different types tell you what happens when you make that selection. And I'll tell you that as we discuss these, they're probably going to look really obvious and intuitive, and they are. They're pretty basic, but there are a few aspects of them that are a little tricky to get the hang of. Once you're used to them, they're second nature, but it might take a little practice to get used to them. All right, so let's look at them. First up is creating a brand new selection, and then we have adding to a current selection, which just means whatever was selected will stay selected, maybe some more will add. We can remove selected features from the current set. We can take that current set and only select a subset of it, or we could flip the selection, and you'll get the hang of these in the lab exercises. Now, these selection types are available in both the Select by Attributes and the Select by Location tools, so get used to them in both places. Now, starting off, making a new selection. This will first clear out any currently existing selection. It wipes the slate clean. The new set of selected features will therefore be completely unrelated to any selection that may have existed previously. Adding to a current selection will leave your current selection, if there is any, unchanged, and then it just adds any newly selected features. Removing from the current selection will only affect currently selected features, and if any features in your selection area are currently selected, then they will become unselected. If they're not currently selected, then they will stay unselected. And then selecting from the current selection. This is actually a really commonly used tool. I use it quite a bit. It only affects currently selected features. If any features in your selection area are currently selected, then they will be left selected. And this means that they're left unchanged. And if features in your new selection area are not currently selected, then they will be left unselected. Any originally selected features outside of your new selection area will be unselected. And this means that if you don't have any features selected before you try this selection type, then by definition you're going to have no features selected afterwards. Remember, it only considers the currently selected set. This is a common problem, that you forget that the selection type is set to select a subset and no features are currently selected, and you just got to be watching for that. Now, switching the selection simply flips the selection state of all the features. If a feature was selected, it becomes unselected, and vice versa. There's tools to switch the selection in a couple other places too. There's a button to do it here in the Feature Attribute table, the Switch Selection button. You can also right-click on the layer name in the Contents pane and then go down to Selection, and then there's an option to switch selection there. And selection types are also available when selecting right on the screen, like you see here. Now, how do you know how many features are selected? This is an important question, and there's two good places to find it. First off, you can find it right in the Attribute table right here at the bottom. Alternatively, you can find it in the Contents pane. You just switch the sorting order to List by Selection, and you see the numbers right here in the column. This is probably the easiest and most informative way to do it. Oh, and by the way, a quick note on determining how many features. Sometimes you see this number star 2000, or in ArcGIS Pro sometimes you see star 100,000 instead of the true number of records. This is because ArcGIS Pro is only looking at that first 2,000 or 100,000 records. It's not actually checked the table further to see how many records there really are. And it does this for performance reasons. It's just more responsive to you if it only loads up the first set. But this means you have to force ArcGIS Pro to look at the entire table before you can see how many records there are. And when this happens, you'll see this little Load All button. You just click it, go to the end of the table, and you'll see the correct number of records. And here's a common mistake. When you want to know the number of selected features in a feature class, look at the selected features for that specific feature class. Don't look down here in the bottom right corner. This number you see down here is the number of all the selected features from all the layers in the map. And it can trip you up because it's not the number of the selected features from that single feature class you were querying about. Now, if you just care about the number of selected cities, for example, then the correct value here is 110. This number down in the corner shows the number of all the selected cities plus all the selected states, etc. Okay, and one other quick thing. You might have noticed that all the selections so far, they show up in your map as a cyan color, and you can actually change this if you want. If there's another color that works better for you, it's pretty easy to switch it. Okay, now moving on. Selecting by multiple criteria. Usually your selection is based on multiple criteria, like in this example here. This is an example I did several years ago. We had this grid of potential fishing areas off the coast of Morocco in northern Africa. We were trying to figure out which ones would be suitable for fishing if you were based in this port of ArcGIS. So in order to be suitable for fishing, it had to meet 3 criteria. First off, it had to be greater than a certain distance from shore. This was legislative criteria to keep fishing right out of the port itself. There was a fuel constraint. They couldn't go out too far from the port and still be able to make a living. So there was a maximum distance. And then there was a depth constraint. The fishing equipment would only fish at certain depth ranges. And based on those 3 criteria, these are the grid cells that were considered suitable for fishing. And this is a very common thing to do, maybe even more common than just selecting by a single criteria. And these multiple criteria can include both spatial and attribute queries. And one cool thing about attribute queries is that if you're making a compound selection with multiple criteria, you can actually build multiple criteria into a single SQL query string. Now, for example, if I want to select all the cities that have a population between 1 and 2,000 people, well, that's 2 queries, and so it takes 2 steps like you see here in this slide. And you can also build multiple clauses when using clause mode. It's just 2 ways of saying building multiple steps into your query. Now, this is different than selecting by location. When selecting by location, you can't apply several spatial criteria in a single batch. You have to do several consecutive selections, where each step contains only a single query. And when you do this, the first selection type is always new selection. That wipes the slate clean. And all the selections after that will either add to the currently selected set, it'll subtract from it, take a subset from it, or just flip the selection. Now, when you want to combine attributes and location queries, you again have to do consecutive selections. You can't do both at the same time. And as with selecting by locations, you just do several queries in a row using different selection types each time. First selection type is always make new selection, and all selections after that add to it, subtract, subset it, or flip it. There is an exception, though, if you're into writing code. There are ways to write code where you just build a query that it contains both spatial components and attribute components. But that's getting into the actual internal functions of ArcGIS, and we're not going to cover that in this class. Okay, now back to multiple criteria in several steps. For example, a single criteria might look like this. We're asking how many cities have a population greater than 100,000. And easy enough, we find that 264 cities are like this. Sometimes that's all we need to do, but a more common scenario might be how many cities in Arizona had more than 100,000 people in 2007. This question takes 3 steps to answer. So first we have to select the state of Arizona. In this slide I'm using a select by attributes query, but there's more than one way to do that. Second, we make an initial selection of cities, returning all cities that meet our population constraint. This is back to our 264 original cities. But finally, we apply a spatial query to our cities, selecting a subset from the currently selected cities, namely those currently selected cities that also lie within the state of Arizona. Now, note that if we had not selected the state of Arizona in step 1, then in step 3, we would have selected all cities in all states. We need to make that initial selection of Arizona in order to force ArcGIS to only consider the state of Arizona in step 3. And here we see that 9 cities in Arizona meet the criteria. There's a few things to watch for when building a multi-criteria selection. And actually, if you use the clause mode in ArcGIS, this kind of helps avoid some of these problems. But you should still be aware of these. They do trip people up quite a bit. Now, when you're making a SQL query, each subquery must be a complete query that works all by itself. So, for example, this is correct. You could say that state name equals Arizona, or state name equals New Mexico. So we have 2 criteria, and each of them are stated in a fully workable query. First, state name equals Arizona, and the second fully workable query is state name equals New Mexico. So to contrast, this is not correct. You wouldn't say state name equals Arizona or New Mexico. It's a common mistake, and it's reasonable because human minds understand this query, Arizona or New Mexico just fine, but computers do not. And this is an example where we have to learn how to think like the computer does in order to give it instructions that it will understand. Now here's another common mistake. This one's even worse because the last one we talked about will actually raise an error message. This one won't. So if we want to select both the state of Arizona and the state of New Mexico, we would not say state name equals Arizona and state name equals New Mexico. How many single states are named both Arizona and New Mexico? And like I said, it's not going to trigger an error, but it'll always give you 0 results. So got to be real careful with this one. People make this mistake all the time. Even I make it every once in a while. So I recommend that you think about it like this. When you're setting a query, then ArcGIS will go through your feature class row by row to see if each individual row meets that query, or each individual feature, and therefore the query is being applied to a single feature. Within that single feature or row, you can only have a single value for that one attribute field. Therefore, this query, which is basically asking for cases where a row has multiple values for a single attribute, has Arizona and New Mexico in this single attribute, then it's going to be logically impossible to ever find any such cases. So, word of warning there. Now, next up, remember to watch the map as you make your selection. Take advantage of the fact that you're running a world-class GIS that will instantly show you visually a map of your results. And many errors are obvious, but you got to remember to look. And in this example, I want to select all points that are both within this polygon and 200 meters from a road. Obviously, I've done something wrong since so many points outside the polygon are selected. And I'll tell you what I probably did wrong was I didn't change my selection type. I should have used the select from the currently selected features, but instead I probably made a brand new selection. And you will do this, trust me. So take advantage of the fact that you're working in a GIS. You have maps immediately available after you make your selections. Okay, next topic. We've been discussing selections, but now let's move on to table joins. Now, joining tables means to create a connection between the tables such that the attribute values from one table or feature class become directly available in another table or feature class. And this is especially useful when many records have the same attribute value. Perhaps a code for a forest stand type. Then you have another table that has single records for each stand type but has extensive data within that row describing each stand type. Now, putting the extensive data into a separate table lets you avoid repeating all that data over and over again in the first table, and I'll show you an example of that in just a second. This type of relationship is good for what we call a one-to-one or many-to-one relationships. For example, you might have many timber survey points that classify the forest type as, say, ponderosa pine, and another table that contains a single record describing ponderosa pine forest type. You join the many points to that single record with the ponderosa pine info. There's actually a similar concept called a relate that's good for one-to-many relationships and many-to-many relationships. We'll get into that in a second. Now, here is a scenario crying out for a join. We have a polygon feature class with very little data in the attribute table, and notice that this polygon feature has a very large number of records. We can use the identify command on a spot, and we learn very little about that spot. How useful is it to us really to know that the polygon has a grid code value of 3159? Doesn't do much for me. However, we also happen to have a table just filled with great information about each vegetation class, but which has no spatial objects, i.e. polygons, telling us where that information occurs on the ground. Notice that this table only has 91 records. Remember, the original feature class had over 745,000 polygons, and every polygon had one of these 91 possible vegetation classes. Can you see the logic in putting these 91 records into a separate table? We can either record these vegetation records 91 times or 745,000 times. First option uses much less space on your hard drive, but it does require that you connect your polygons to this table. Here we see that lots of polygons may correspond with a single table record, and this means that we have a many-to-one relationship. many polygons to one forest type record. And this works just fine for many-to-one relationships. We join the table to the polygon feature class, and essentially we have just added a bunch of new attribute fields to the polygon attribute table. But it's important to remember that even though we see this as a single table, with all the veg type info showing up in all 745,000 polygon features, neither the polygon feature class nor the attribute table has been modified on the hard drive. This join relationship occurs entirely in your computer memory, and it only exists in this ArcGIS Pro project. But ArcGIS Pro can now analyze the feature class and the veg type attribute table as if they were a single data set. And now when we click on a point, we see all the joined attribute data as well. Okay, next up, relates and relationship classes, which are similar to joins in that you link tables together. It allows you to get information on a feature by pulling data from different tables. However, they are different than joins in that the linked tables are not merged together. If you open a table that participates in a relate or a relationship class, it will still look the same as it would if it were not participating. That's different from joins. Remember, you join two tables together, you open it up, it looks like a single table. Now, relates and relationship classes are good for one-to-one and one-to-many and many-to-one and many-to-many relationships. Remember, the joins are really only good for the many-to-one and one-to-one, so these have a little more flexibility. Now, the difference between relates and relationship classes, they're almost identical. They both define the exact same types of relationships between tables and feature classes, and you use them exactly the same way. Difference between them is that relates are created in memory in ArcGIS Pro, similar to joins were, and that relationship classes are saved into a geodatabase. You create a relate while within your current Pro session. You can only use it while working within that particular Pro project. Relationship classes, on the other hand, are permanently saved to a geodatabase until you deliberately delete them, and they are accessible at any time from any ArcMap or ArcGIS Pro session. Another difference is that you need an ArcGIS standard or advanced license to create relationship classes. You can't create them using the basic license. This means that if you're working for a nonprofit that's running the cheapest version of ArcGIS Pro, you may not be able to create these relationship classes. Now, relates, on the other hand, you can create using any license level. Okay, the Explorer tool takes advantage of relates. If your feature class has any relates or relationship classes, then you can see all related features and records by just clicking on the feature. And another cool thing, you can actually push a selection from one dataset to another. In this example, we have 27 springs selected. We can push that selection to the surveys table, and we find that there's been 74 surveys performed on these 27 springs. We can further push the survey selection to the invert sampling table. We find that invertebrates have been recorded 655 times over the course of those 74 surveys. Finally, we can push the invert sampling selection to this last invert taxa table, and we see that 203 unique invertebrate species have been observed at these 27 springs. Okay, let's try a couple of demonstrations on this. And we're going to be using your springs data that's in your class data folder. I'm going to be demonstrating relationships between tables that may not be obvious how I'm getting from one table to the other, but this is all in a poster that's also in that same data folder, and your lab exercises will walk through this as well. So don't worry too much if it doesn't make any sense right now. All right, first thing we're going to try is see how these relationship classes can help us find out what Chimney Spring looks like. Happen to know that Chimney Spring is site ID 802, so I'm going to take advantage of our new Select by Attribute skills to select that spring. Okay, where site ID equals 802. Here's what it looks like in SQL. Hit OK. All right, we have a spring selected. We're going to zoom into that spring. Okay, I'm going to use the Explorer tool to click on it. We'll get all the standard information we normally do with the Explorer tool. See, this is all the information that's in the Springs feature class itself, but we're going to take advantage of the related tables. So to get to the images, we have to click on the little triangle here. This shows us all the tables that are related to the Springs feature class. We're going to pop down to Surveys, See that 4 surveys have been recorded for this feature class. Now some of these have images and some don't. I happen to know that this one has an image or two, so I'm going to open up this survey. This, by the way, is the information recorded right in the surveys table, but we're going to go to another related table called Table Images. Let's open that up. We see we have 3 images recorded for this particular survey. So to see one of the images, we just pick one of the images in this list here. We come over here, click the link, and it pops it open in a web browser. This image is actually sitting over on the Springs Online database, so ArcGIS is reaching out into the internet to see it. So that's a sketch map that somebody drew of the spring on one of the surveys. This one here has an image, photograph somebody took of it. So this is what Chimney Springs looks like. And that's how you can use the Explore tool to navigate the related tables. Okay, next demonstration. We want to know what vertebrate species have been observed at springs on the Mormon Lake District. Well, this will require us to navigate from the Springs feature class to the Surveys table to another table called Vert Survey, which records all vertebrate species ever recorded on any survey. And then from there we'll navigate to another table called Taxavert. This is where we keep our list of unique vertebrate species. All right, so it'll be, we're going to, and for this one we're going to have to push selections. This isn't something we can answer in that Explore tool. So we're going to do a select by attributes to first select the springs on the Mormon Lake District. So we hit select by attributes. This query is, we have to search for the land unit detail is equal to the Coconino National Forest Mormon Lake District. This is what it looks like in SQL. Okay, we hit OK to select those springs. They have been selected, looks like 74 of them. If we want to know where they are, we can right-click on the layer, go to Selection, and zoom to Selection. And here they are, the springs on the Mormon Lake District. Now, we want to know what vertebrate species have been observed there. So let's start by opening up the attribute table. Okay, here's our 74 springs. Now we have to push this selection to the surveys table. There's a couple of ways you can do it. First off, you can do it here in this little, they call it a burger. You click on that, go down to related data, and then connect with the surveys table. Okay, this tells us 262 surveys have been performed on those 74 springs. So we push this selection to the Vert Survey table. We could do it from here again, related data, where's Vert Survey? Here it is. We could push it there. There's another place you can do it, though. If you're in your map tab up here, if you click on Table, there's a command for related data. It takes you to the exact same list. So we're going to go to Vert Survey. It does the exact same thing. So we see 435 vertebrate species have ever been recorded in any of those surveys. Now we need to get a list of the unique species. That's in the Taxavert table. So we push this one more time. And these are the 107 unique vertebrate species that have ever been recorded as springs on the Mormon Lake Ranger District. If we wanted to, we could export this data to like a CSV file, and then we have a table we could put in a report or anything we wanted to do with it. All right, so that's how we figured out the vertebrate species. Now, next one, what springs have western tanagers been observed at? This is actually real similar to what we just did, but going in the other direction. I mean, last time we started with the springs, we pushed the selection to the surveys, then to the Vert Survey, then to the Taxavert. Well, now we're going to select a record out of Taxavert and just push that selection in the opposite direction until we get back to the springs. So western tanagers, I just like those. That's why I picked that one. So here it is. I can start here. I can just reselect this. This button up here will take any highlighted record and make it the selected one. So I'm just going to choose that. So now we have western tanager selected. Well, I have to push that selection to the Vert Survey table. So I'm going to use my little burger here. Vert Survey. Okay, so 11 times a western tanager has been recorded at Springs and the Coconino. We're going to push this one more time to the surveys table. Okay, those 11 observations occurred on 11 different surveys. So last step is to push it back to the Springs. I'm going to click here, related, Springs. All right, so 11 springs in which the western tanagers have been observed. So let's take a look at where they are. Here's one, here's one, here's one. Let's zoom to the selected again. Selection, zoom to selection. All right, so I can kind of see them. I don't think Pro does a great job at really bringing out selected features. It's kind of hard to see here. So I'm going to do another thing that's kind of fun. You can, if you have any selected features, you can right-click on the layer, go to Selection, and there's a thing called Make Layer from Selected Features. We do that. It makes a new layer. It's pulling from the exact same data set, but it's actually only showing those features that were selected. And this is where they are. If you want, you can have a little more fun with it. You can change the symbology. There's some kind of fun symbology options. I was playing around earlier and I just made one I kind of liked, and so I'm just going to symbolize it by my little bird silhouette. All right. And here are where the western tanagers have been observed on the Coconino National Forest. All right, thanks so much. Now this geodatabase is actually pretty cool. It makes better use of relationship classes than any data set I'm aware of. So I've got you a copy of it. And we also have presented this geodatabase at conferences here and there. And so I've got a copy of one of our presentations for you to look over. It'll give you a better introduction into the geodatabase itself. So go ahead and take a look at that once you're done with this lecture. All right, and thanks so much. I appreciate your time, and let's get on to the labs.